Hello, Mr. Beeline here with your science lesson for today. We are talking about electrical potential energy and voltage. Voltage gets thrown around as a term a lot when we're talking about batteries. Why is this? It's because batteries store energy. And they also convert this energy. This energy is normally stored in chemical form, and then it's converted to electrical form. Right? And it's super interesting how they do this. Now, with any battery, so for example, we've got like a AA here, you're going to have two terminals. One is positive, one is negative. And inside the battery is a separator, right? It prevents the battery from having all the electrons contact all the positively charged chemicals, and it would just be neutral, right? Nothing would happen. But if we put a barrier in between, then they can't come in contact with each other, and the only way that the negative charge is going to get to the positive charge, right? Because they're opposite charges, they want to be together, different charges attract, is if we plug it into something like a car or into a phone or into a gaming controller or something, right? We're going to plug it in so that there is some sort of circuit happening, right? Where the negative now has a pathway to get to the positive side, right? Again, opposites attract, so the negatives are going to go through the path of least resistance to get to the positive. So as soon as you plug it in, there we go. Your negative charge is going to move to your positive side, and by doing that, the chemicals are going to turn into electrical energy, because electrical energy is the movement of electrons, and then by passing through whatever is going on in your circuit, you're going to have your power, right? You're going to have your video games turn on or whatever. Now, the potential difference between 2 points, right? So the difference in potential energy from one side to another, from here to here, this is known as voltage. Okay? And voltage is measured in volts. And we use a V. So again, potential difference is how much energy could possibly be transferred between, or possibly move between 2 points in your circuit, right? And so that's a little weird to think about just by looking at this drawing, but let's consider a hill. Right? Let's look at this hill. And we have this rock down here. It's at the bottom of the hill. It's not moving, right? So it's like a dead battery. It doesn't do anything. But if we push this rock all the way up to the top, right? We push it all the way up to the top, and it's just sitting there. Right? It's just sitting there. It doesn't have anything else to do. It's got potential energy there. It could do something. With a little bit of a push, it could go all the way back down, right? With a little bit of a push, we could have this rock move downwards, right? So that's the same idea here. With a little bit of a push, we can put it into a circuit and we could have that energy. So the voltage, or the potential difference, or the potential energy, is this possible energy that could be happening here. It's not necessarily the actual movement, it is just the potential for it. Okay? So that is voltage represented in, a gravity and a hill and stuff like that. But this type of concept is actually happening inside the battery as well. Okay, that's it for this lesson. Again, feel free to have a look at the written explanations to clarify anything there. Send me a message if it's still a little confusing. I can try and explain it through a couple other ways too. And there is going to be a worksheet attached to it too. So please check that out and get it handed in when you can. Okay.